Welcome to The Explainer. Today we're going to uncover a little bit of mathematical magic. We're going to see how you can create this absolutely beautiful, intricate art from just one super simple rule. So just look at this incredible shape. It's this stunning, heart-like curve. It's called a cardioid. But here's the crazy part. What if I told you that it's not actually a curve at all? Seriously, it's an illusion made entirely from hundreds and hundreds of perfectly straight lines.
So the big question is, how is that even possible? How do you get a perfect curve from only straight lines? It really does feel like a magic trick, right? Well, today we're going to pull back the curtain and learn exactly how it's done.
Okay, so let's get right into it. The secret here, it's not some crazy complicated formula. Nope, it's just one simple instruction. Think of it like a recipe for making amazing art, and all you need to start is a circle.
Okay, here it is. The rule. Imagine you've got a circle, and all around the edge there are points, evenly spaced out, and they're numbered one after the other. Now, all you have to do is connect every point, let's call it point K, to the point at position 2K. That's it. So point 1 connects to point 2. Point 2 connects to point 4. Point 10 connects to point 20. You get the idea. It's kind of like a game of connect the dots, just with this really cool mathematical twist.
You know, there's another way to think about this which might make it even clearer. Instead of point numbers, let's think in terms of angles. So if a point is at a certain angle, we'll call it alpha. The rule is just to draw a line to the point that's at double that angle, which we'll call beta. That's the whole secret sauce right there. That simple doubling action is the engine that makes this whole thing work.
Okay, so you might be wondering, what happens when you double a number and it goes way past the last point on the circle? Like, say you have 360 points. Where does point 200 connect? Well, 200 times 2 is 400, but there's no point 400. So what do? Simple. You just wrap around. It's like a clock. You go all the way around past 360, and then you just keep counting for 40 more spots. That lands you on point 40. This whole wraparound idea is a really important concept in math called modular arithmetic, and it's the key that keeps all the lines neatly inside the circle, creating this amazing pattern.
All right, so we've got our circle. We've got our rule. Now for the fun part. Let's actually watch the magic happen. We're going to see how this beautiful shape just emerges, line by single line, as we apply that instruction again and again.
So when you first start, honestly, it doesn't look like much of anything. You just get these lines crisscrossing the circle, and the pattern feels kind of random. You can see it happening, right? Point 1 goes to 2, 2 goes to 4, exactly what the rule says. But where's the heart shape?
But then you keep going. You keep adding more and more lines, and all of a sudden, something absolutely incredible starts to happen. Do you see it? A distinct inner curve just starts to appear, like it's emerging from the chaos. Every single new line we draw just barely kisses the edge of this invisible curve, slowly tracing its outline. It's pretty amazing. And there's a cool name for this in mathematics. It's called an envelope. It's a curve that's perfectly touched by every single line in the group.
And there it is, the final result. After all those hundreds of straight lines have been drawn, together they have created this one perfect, beautiful heart-like curve. The magic trick is complete.
But hold on. All of this was just using the number 2 as our magic number. So what happens if we change the rules of the game? What if we connect point K not to 2K, but maybe 3K or 4K? Does the magic still work? Well, let's find out. So on the left, you can see our original cardioid. That's the times 2 rule. And on the right, that's what happens when you use a times 3 rule. Whoa, the heart shape is totally gone, and instead we've got this beautiful new shape with 2 sharp points, or what mathematicians call cusps. Just think about that. One tiny change to the rule, and you get a completely different piece of art.
And it doesn't stop there. Look at this. When we multiply by 4, we get 3 cusps. When we multiply by 5, we get 4 cusps. Are you seeing the pattern here? The number of these cool points, these cusps, is always just one less than the number we're multiplying by. It's so neat. And these incredible shapes are all part of a bigger family of curves called epicycloids.
So, the really mind-blowing thing here is that this super simple system can create almost infinite complexity and beauty. I mean, just check this out. This is what you get when you use a multiplier of 26. Look at that intricate web-like pattern. And it all comes from that exact same simple times table rule. Okay, so this is all cool to see on a screen, but this isn't just some digital computer trick. You can actually bring this mathematical art to life in the real world.
People actually make these. You can use something like this 3D printed loom with all the pegs around the edge, or you could totally do it yourself with a piece of wood and some nails hammered in a circle. All you do is take some string or thread and just start connecting the pegs, following whatever rule you picked.
And it's supposed to be a really rewarding, almost meditative process. If you just stick with the rule and you're patient, you will literally watch this heart shape appear right before your eyes, one piece of string at a time. How cool is that?
So hey, why not give it a try yourself? It's pretty simple. Start with a circle. Add some evenly spaced pegs or nails. Pick your rule. You could do ×2 for that classic heart shape, or get adventurous and try ×3 or ×4. Then just start connecting them with string and watch your own amazing piece of mathematical art take shape.
It really leaves you with a pretty amazing thought, doesn't it? If a shape as perfect and beautiful as this can be hiding inside a simple multiplication rule, it just makes you wonder what other incredible patterns, what other hidden beauty is just waiting out there to be discovered in the world of math.